Hello everyone. Today we're looking at solving problems involving rates. So here we have a bunch of different unit rates used in everyday life. These might describe something like heart rate, wage, price of gas, AM radio frequency, file transfer speed, and pressure in a tire. Unit rates help when trying to compare quantities. So this first question we're going to look at, one bakery offers scones for $2.60 or $30 for a dozen. Another bakery offers similar scones for $3 each, but offers a baker's dozen for $31. Johnny needs 16 scones for the math meeting. Where should he buy the scones if he wants to spend the least amount of money? So looking at this first bakery that sells scones for $2.60 each, or $30 for a dozen. Dozen, by the way, is 12. If you were to buy 12 scones individually, that would cost $31.20. So there's a bit of a bulk rate discount at this bakery, as well as the other one. So with this bakery, let's call it maybe Bakery A, buying 12 scones would cost $30. And if we need 16 total, that means we need to buy 4 individually. So added to 30, we would have to buy 4 at $2.60 a piece. So 4 at $2.60 works out to be $10.40, and $30 plus $10.40 gives a grand total of $40.40. Now for Bakery B, they sell scones $3 each, and a baker's dozen, which is 13, for $31. So for comparison, if he bought 13 scones at $3 a piece, that would cost him $39. So this second bakery, let's call it Bakery B, we can buy 13 scones for $31, and we'd need to buy 3 additional scones at $3 a piece. So 3 scones at $3 a piece makes $9. If we add 31 and 9 together, we get a grand total of $40. So if we're shopping for scones and trying to spend the least amount of money, we should go with Bakery B. In question number 2, the Students' Council is ordering pizza for the volunteers at parent-teacher interviews. They estimate they will need 2.5 slices per volunteer. There are 52 volunteers and each pizza has 8 slices. So how many pizzas do they need to order? Well, it would be helpful to figure out how many slices of pizza total we need first. So given that there are 52 people and each person is capable of eating 2.5 slices of pizza, we basically multiply 52 by 2.5 and this sort of cancellation happens and we're left with the number of slices. So that works out to 130 slices. And given that each pizza has 8 slices in it, the remainder of the problem boils down to how many times can you fit 8 into 130. So 130 divided by 8 gives us 16.25 pizzas. But we generally can't buy a quarter of a pizza, so that'll mean we'll have to buy 17 pizzas. In question number 3, Miss Dessens and her husband ride their bikes on wind trainers set up in their basement. Miss Dessens can burn 500 calories if she rides for 55 minutes, and her husband can burn 400 calories in 35 minutes. Miss Dessens rode her bike one Saturday morning and burned 875 calories. How long did her husband need to ride in order to burn the same number of calories? It'd be helpful to start by figuring out a unit rate that lets us know how many calories each person burns per minute. And in this question, it would be helpful for us to assume that the intensity is the same regardless of whether they're riding their bikes inside or out. So we can start by figuring out the rate of calories burned by Miss Dessens. On the wind trainer, she burns 500 calories over 55 minutes. So we simply go 500 calories divided by 55 minutes. And in our calculator, we just go 500 divided by 55, and that gives us 9.09 calories per minute. Next, we can find the rate for her husband. So he burns 400 calories in 35 minutes. So in the same type of calculation, we go 400 calories divided by 35 minutes. We just do 400 divided by 35, and that gives us 11.43 calories per minute. So next we need to look at her Saturday morning bike ride, where she burned 875 calories. So if she burned 875 calories, and we know she burns 9.09 calories per minute, we can figure out how many minutes she rode. Now this doesn't necessarily answer the question directly, but it's a little bit helpful. So we basically need to figure out how many times 9.09 fits into 875. Because in 1 minute, Miss Dessens would burn 9.09 calories. Over the course of 2 minutes in exercise, she would burn 18.18 calories, and so on. So we basically need to divide 875 by 9.09. We can also set up this division like this. So we need minutes, and we're looking to cancel calories. So she does 9.09 calories per 1 minute, and if we divide 875 by 9.09, we get 96.25 minutes. So calories cancel, and we're left with minutes. And now for her husband, he needs to burn 875 calories, and he burns 11.43 calories per minute. So in order to figure out how many minutes he was cycling for, we just basically need to divide 875 by 11.43. And we can set the division up the same way we did with Miss Dessens. So we need to have minutes left over, calories needs to cancel. He burns 11.43 calories per 1 minute. So when you divide 875 by 11.43, you get 76.56 minutes. So again, calories cancel, and we're left with minutes. So this is the answer to the question, how long did her husband ride in order to burn the same number of calories? And we're assuming his intensity is about the same as her ride, because if he switched to an e-bike, for example, he might need to go a while longer to burn the same number of calories. For question number 4, Johnny searches through Google to determine the driving distance to Vancouver. Google states that the driving distance from Calgary to Vancouver is 972 kilometers and can be driven in 10 hours 37 minutes. He decides to make the trip and assumes all that Google states is true. So first we need to determine his average driving speed in kilometers per hour. So speed is given by distance over time, and we have a distance of 972 kilometers. And we also have a time of 10 hours 37 minutes. So I'm going to do a quick speed calculation, and I want you to spot the error. So 972 kilometers, 10.37 hours. 972 divided by 10.37 gives me 93.73 kilometers per hour. Can you see what I did wrong? 37 minutes is not equal to 0.37 of 1 hour. That would only be true if 1 hour equaled 100 minutes. But we know better. 1 hour equals 60 minutes. So in order to determine the equivalent time this works out to in hours, we need to divide that number by 60. So 37 minutes times 1 hour per 60 minutes gives us a time of 0.616 repeating hours, because minutes cancel and we're left with hours. So 10 hours 37 minutes would represent 10.616 repeating hours, and not 10.37 hours. And now we can figure out the speed. So speed is 972 kilometers divided by 10.616 repeating hours. And if we do 972 divided by 10.616, we get 91.55 kilometers per hour. Moving on to B, the fuel efficiency in liters per 100 kilometer. If his car used 85 liters of fuel for the entire trip, we can start by going 85 liters divided by the distance of the trip, which is 972. And if we do 85 divided by 972, we get 0.0874 and some other digits liters per kilometer. Now that's a unit rate and not exactly what we were told to find. So as it is right now, it's 0.0874 liters per 1 kilometer, and we need to switch it to liters per 100 kilometers. So in order to accomplish that, we can multiply the top and bottom by 100, which is essentially the same as multiplying by 1, so it leaves this number unchanged. So the top times 100 works out to 8.74 liters, and the bottom times 100 is 100 kilometers. So his fuel efficiency is 8.74 liters per 100 kilometers. So for part C, we need the average price per liter of fuel in dollars per liter if he spent a total of $124.67 on fuel. So we need dollars up top and liters on the bottom. So dollars on top, $124.67, and liters on the bottom. He used up 85 liters in total. So all we do is 124.67 divided by 85, and we get $1.47 per liter. So in question number 5, we're looking at a map of Calgary. The scale on the map is 1 centimeter to 20 kilometers. If Calgary is approximately 50 kilometers from north to south, and 35 kilometers from east to west, we need to determine a few things. So first we're looking to determine the area of the map representing Calgary, assuming that Calgary has a rectangular shape. So here's an accurate depiction of Calgary from the air. From north to south, it's 50 kilometers, and from east to west, it's 35 kilometers. So now we need to shrink this area down so that it would fit on a map. And for the map we've chosen, 1 centimeter equals 20 kilometers. So here's our tiny map. and we need to shrink the actual area down so that it fits onto the map. So what we need to do is take this equation and arrange it into a fraction so that we're left with centimeters and kilometers cancel out. So at this point there's only two possibilities. We could either go 20 kilometers per 1 centimeter or 1 centimeter per 20 kilometers. We need to pick the correct one so that kilometers cancel out. So which one should we pick? We should pick this one. So if we multiply 35 kilometers by 1 over 20, so that's essentially like going 35 divided by 20, we get a width of 1.75 centimeters. And if we do the same with 50, so 50 times 1 over 20, or equivalently 50 divided by 20, we get 2.5 centimeters. So given that the area of a rectangle is length times width, we just go 1.75 centimeter times 2.5 centimeter. And we get a map area of 4.375 centimeters squared. Next, we need to find the population density in people per kilometer squared if Calgary has approximately 1.2 million people. So we need people up top and kilometers squared on the bottom. So 1.2 million people looks like this, and we divide that by the actual area, which would be 50 times 35. Now 50 times 35 gives us 1750 kilometers squared. So now all we need to do is divide 1,200,000 by 1750, and we get a result of 685.7 people per kilometer squared. In this last question we'll go over together today, the drawing in a biology book of an ant has a length of 10 centimeters, and we need to determine the scale of the drawing if the actual ant is 4 millimeters long. So at the moment it's a little bit difficult to make a direct comparison because we have centimeters on one hand and millimeters on the other. So it would be helpful to know first that there are 10 millimeters in 1 centimeter, and you can confirm that by looking at a ruler. Now scale is typically given as model to original as a ratio, and in order to get a unitless ratio, we need to make sure that these units are the same. So given 10 centimeters, we have 10 lots of 10 millimeters. So that would be 100 millimeters total, and that's our model, and the original is 4 millimeters. Typically scale drawings are given as unit ratios without units. So in order for us to get a unit ratio out of this, we can divide both sides by 4. And 4 divided by 4 is 1, and 100 divided by 4 is 25. And millimeters basically cancel out because it's a 1-to-1 comparison. So the scale in this biology textbook is 25 to 1. If this step was a little bit of a stretch for you, you can generally use your calculator to reduce the fraction for you. This would give you 25 over 1, or if you did it the other way, 4 over 100, it would give you a fraction as 1 over 25. So that's it for me for today. I'll get you to do these two questions, and I'll see you next time.